Now, if we're talking about big data, Twitter's got a lot of data. Can you give me an update on stats?
I actually don't know what stats I'm allowed to reveal, but
okay.
We do have a lot of data. It's growing every day, and we're happy about that. We have to process all of it in real time, which is a big challenge for us.
Okay, well, I did get to interview someone yesterday about ingesting the whole archive and getting it out to the CEO of DataSift. And he mentioned something between 250 and 300 million tweets a day that they're ingesting. So that's some context.
Yeah, that's a lot of data.
It's a lot of data. So part of the challenges with a lot of data is how to build architectures to handle them. And as I look back, I've been tweeting since 2007. I remember seeing the fail whale surface a lot,
right.
And part of that's around the architecture, right?
Yeah.
Something that you as an engineer know lots about.
Yeah.
As I understand it, Twitter was originally built using Ruby, but then moved to a new architecture to meet demand. What did you build to avoid the fail whale surfacing again, and how?
Yeah, well, I think a key thing for getting reliability and robustness is this notion of fault tolerance, right? You need to be able to withstand failures to your machines or failures that can happen in your processing. I think one thing, a lot of people are familiar with this idea of machine fault tolerance. I think one thing that people don't talk about as much, but which is just as essential, is this notion of human fault tolerance. If we know anything from software, people have been doing software for a long time, it is inevitable that sometimes programmers make mistakes and bugs reach production, and that can cause damage. And you actually, if you really want to make your systems reliable, you have to engineer for that human fault tolerance as well. And that goes, you make different decisions when you think about human fault tolerance. There's a lot of techniques you can use, like making data immutable and using batch processing and recomputation, which can really help you recover from mistakes. And we do a lot of that. And that goes a long way towards keeping our systems reliable.
In terms of the tools that you're using to do that, you're seeing a steady stream, I think, of open source tools that Twitter has built internally that you're then releasing. Can you give some examples of what they are and what they do, and maybe why you're doing that?
Yeah, well, open source is kind of one of the core philosophies of Twitter. We just think we use so much open source from that other people have built. We feel it's just right for us to release as much as we can open source. And just as an engineer, I really like working on open source, and as do my colleagues and as do most people. We've open sourced a lot of projects. Some of the higher profile ones have been things like Finagle, which is a network library, FlockDB, which is a social graph database. I personally have been responsible for a few open source projects. One of them is called Cascalog. So this is actually a competitor to tools like Pig or Hive, and it lets you process data on Hadoop using Clojure. I also wrote a database called ElephantDB. So ElephantDB is optimized for exporting data from Hadoop and serving it in a read-only fashion. The project I'm probably most well known for is a project called Storm. And Storm is a real-time computation system. I like to say that Storm does for real-time processing what Hadoop does for batch processing.
Okay, and if people want to take a look at Twitter's open source stuff or yours, where can they go online?
So most of the projects are on the Twitter GitHub, so github.com/Twitter. My projects are actually on my GitHub, which is github.com/Nathan Marz.
Nathan Marz, okay, great. So last question, and this kind of goes to back to the very beginning. When you look at how social data is growing right now, and the rate that Twitter is growing too, how do you expect do you need to re-architect the system in the next year or two? Will you think you have to revisit how it's being built, or and if so, why?
So at this point, we're still in some respects in that transition phase. Twitter had a large legacy architecture, and it takes a long time to migrate it towards more reliable, more scalable systems. But we're making a lot of progress on that. And Storm is certainly a big picture in that. We do think that we do have it figured out, though, at least for a long time. All of our systems now are fully distributed, fully fault tolerant for both batch and real-time processing. And they're all horizontally scalable. So if we grow 10 times bigger, then we can just add that many more machines, grow our data center, we don't need to re-architect things because things are fundamentally distributed, fundamentally parallel, and fundamentally fault tolerant.
Okay, great. Well, thank you, Nathan. Appreciate
absolutely.
it.
Yeah, thanks for
having me. So that was Nathan Marz. He is at Nathan Marz with a Z on Twitter. If you check out his stream, you'll be able to find his GitHub account to store him and lots of other projects he's working on.